Welcome to Ask and Learn.
Hi, in the given problem, the football player covers the total distance in two modes. First, he runs for the 16 yards at accelerated motion with accelerated motion. Suppose from A to B, this is accelerated motion. And out of total 40 yards, the remaining 24 yards, he runs at constant speed. Now, first of all, we will convert these yards into meter. As we know, 1 yard is equal to 0.914 meter. So, 40 yards will be 36.576 meter and 16 yards will be 14.63 meter. The motion is resolved into two parts, A to B, accelerated motion, and from B to C, uniform motion. Suppose he takes time t1 here for accelerated part of the motion, and he takes time t2 for the uniform motion. So, first of all, for accelerated motion, suppose acceleration, which is missing. Suppose it is A. Hence, initial speed Vi is 0 as he starts running from point A. The final speed achieved at B, that is also missing, unknown. Total distance traveled from A to B, let it be S1, that is 16 yards, or we have converted it into meters, 14.63 meter. Hence, using third equation of motion, which says Vf square is equal to Vi square plus 2As. So, putting the known values for Vf, this is unknown, so it will remain same. Vf only is equal to 0 for Vi plus 2A, acceleration is also missing, into 14.63. Here it comes out to be 29.36 A. So, Vf, the final speed achieved at point B, is the square root of 29.36 A. Now, for the same part of the motion, we will use second equation of motion. So, now using second equation of motion, which says total distance S is equal to, let it be S1, is equal to Vit plus half A T1 square. So, this S1 is 14.63 meter again. For Vit, this is 0 again, plus half A into T1 square. So, T1 square comes out to be 2 times of 14.63 divided by A, or we can say this T1 is the square root of 29.36 divided by A. Now we will switch over to the uniform motion. Now, for uniform motion from B to C, the remaining distance S2 is 40 yards minus 16 yards, or in meters we can say 36.576 minus 14.63 comes out to be roughly 21.95 meter. Hence, time taken for this part of the motion to complete is equal to, simply using time equals to distance upon speed, S2 by Vf, because the speed achieved at point B now will remain uniform. So, This S2 is 21.95 and VF we know that is 29.36A. So according to question, the total time taken by the player is 4.25 seconds. Hence, putting the values of both of these times for T1, this is square root of 29.36 by A, and for T2, this is 21.95 divided by square root of 29.36A is equal to 4.25. Now, if we make a square root of this 29.36, it comes out to be 5.42. In the denominator, it remains the square root of A. Plus here also 21.95 when will be divided by the square root of 29.36, which is 5.42. We will get here 4.05 divided by square root of A equals to 4.25 seconds again. Now finally adding these two terms in left hand side, square root of A, and in numerator 5.42 plus 4.05 will come out to be 9.47 is equal to 4.25, or the square root of A is equal to 9.47 divided by 4.25 seconds. So here it comes out to be 2.23 seconds. So finally, making a square of both the sides, acceleration of the motion, accelerated part of the motion comes out to be 4.97 meter per second square. This is the answer for the first part of the problem. Now we have to find the time taken by the player for accelerated part of the motion, and that is given as T1 is equal to square root of 29.36 divided by A, or we can say this is 29.36 divided by 4.97, which comes out to be square root of 5.907. So finally this T1 comes out to be 2.43 seconds, and here it becomes the answer for the second part of the problem. Thank you.